floor is yours.
Okay, hello everyone. I hope you can see my presentation at the moment.
I can see your screen indeed. Yes, yes. LAMAlib.
Great. So yes, it's about an assembler macro library, and it's basically macros and a library, which can be currently used for the VC20, C64, and C128. And it was made as a lightweight assembler macro library. So it's something that you can use in addition when you're doing assembly coding. So it's not necessary that you use it all the time, and you can also do all your normal coding routine and probably just use a few functions. If you just want to use a random function or something, it should not produce any overhead. If you don't use functions there, they don't add to it. Currently, it's aimed to these 3 machines. This has mainly to do with my background. So I never owned a C16 or +4, unfortunately not also a pad. But given that that they're also based on the 6542 and that CC65 supports them, there shouldn't be any problem to extend it. And it's on my to-do list. And as I already said, it's a little bit more than a macro package because it also contains a function library. And yeah, basically macros for 16-bit operations, macros for structured programming. This is something you don't see often with assembler macros for being able to do structured programming. Some useful library routines that can save you some time. The support for the 3 machines is basically functions that adjust to the address layout of the target machine. And currently I'm also working on a high-res GFX part, which is not yet done. Also, this will require a lot of adjustment to the different architectures other than the normal functions. My motivations to make this were, first of all, to reduce complexity. So I like to join, for example, game jams where you have to write like a game on one weekend, which means you have to be very fast, and you should not lose much time on writing lengthy code or copy routines or so. It's often more important to just quickly write the code. It's not of utmost importance that the code is the fastest code possible. So it's more like development speed rather than optimized code. And here is some example for which a friend of mine needed copying the basic ROM into RAM on the C64. So you basically make a loop where he did it in BASIC. You make a loop over the 8 kilobytes and read each byte and write it back there so it ends up in the RAM. And in LAMAlib, you can do it almost with the same level of complexity than you would do it in BASIC, but it compiles to much faster code. It's not the fastest running code that comes out of this, but it's the fastest way to type it in. So my second reason to do it was to reduce the need for labels, because those create potential mistakes. Can you spot the mistake in this code here? So this code assembles, and it's 2 parts of code copied, and then some values have been adjusted to do it first on the source address and then do it on the branch target, exactly. So when copying, I forgot to adjust the branch target. The problem is the branch target exists, and also it only happens on the high byte. So this would be also a bug that would be hard to detect because it would not surface most of the time. And this is something that happens to me a lot. I don't know, probably I'm not experienced programmer enough, but it just happens. And by reducing the number of labels, you can avoid these kind of problems. And for a third reason, which is kind of connected to the first one, sometimes I have algorithms written down in BASIC or written down in C, and then I want to convert them to assembly. And in assembly, you have basically the equivalent of a goto, but you don't have equivalent of an if, of a switch, and also what you heavily use for, and what you heavily use in C would be while loops. Being able to use this kind of structured programming makes it easier to just make a mapping between your C code and the assembly code. So in bold here, you see some new commands that are supported by LAMAlib. Just very quickly, so what's the difference between macros, subroutines, and a library? The macros are something that are replaced directly in the code. So every time you use it, the full length of the macro is used. So in this case, it would be 8 byte. It's not that easy because if it would be 0-page addressing, it would be less. There is a mistake in the comment here. It's 3 plus, when address is in 0 bytes, no, it's fine. It's 3 plus 2 plus 3 byte, but it would be 2 bytes less when address is a 0-page address. But this would be an example for a macro. And then, of course, you can have subroutines, and subroutines only cost you the jump subroutine command to use them every time. So cost for additional call is 3 bytes. But when linked as an object, it is added to your program nevertheless. So if you have a library, if you have a subroutine which you don't use, it takes up space if you link it to your program. In addition, it gives you a small timing overhead. Small, depends on your requirements. But it also gives you some timing overhead because you have to do the jump subroutine and the RTS. In contrast, you can also do the same stuff via a library function. And this also works with subroutines. And in this case, it is only linked to your program if there is a reference to it. And the CL65, so the linker of the CC65 environment, supports libraries so that you can automatically avoid including stuff that you actually don't call and that you don't need. So unused functions don't cause an overhead. And this was a great way to introduce a lot of functions to make like a big catalog of useful functions. And on the other hand, ensure that you don't add any overhead to your program in case you don't need them or because you don't call them. So we have a big library, but a small overhead or no overhead to your program if you don't use any functions. We use LAMAlib, so it's available on the GitHub page, and there is an installation script that comes with it. And the installation script copies some files into the include and library directory of CC65 if you find CC65 installed on your system. And if this succeeds, then you only have to include, add a line include lamalib.inc at the beginning of your code. And when linking, you need to add this -lib lamalib.lib in your linking command, which adds the functions that you refer to. It doesn't add any functions if you didn't refer to them. If you only use macros, you can even omit the adding the lib, but it doesn't come at any cost, so it doesn't matter if you add it anyway. It also comes with a script as, which just means assemble, doesn't mean anything bad, which adds also a basic stub to your program if you don't specify a target address. So you can write a short assembly program with LAMAlib as it, and then you get something that is runnable right away. A very short overview on the macros. So it first contains something which you probably have seen before with other macro libraries or macro packs, 16-bit macros, just things that do more or less the same that the standard 6542 commands can do, but for 16-bit. In LAMAlib, there is, since in CC65, A that registers A and X are often used as a 16-bit register. LAMAlib does the same. So it's using AX. And so for each or for almost all commands that operate on the accumulator, there is a version that is using AX. So there is, instead of LDA, there is LDAX, and you can load a 16-bit value into A and X. You can load from an address. You can add to AX. You can roll, ROR, EOR, compare, store, just the usual stuff. There are also some macros that are operating on memory. They have the suffix 16, so decrement 16, increment 16. And as a courtesy to guys who like BASIC, like me, I even added a poke and a poke word macro, which just loads the value into accumulator and stores it into the address. But it just saves me some lines using poke instead of LDA, SDA. Then there are some convenient macros and subroutines for outputting stuff. There is a print AX, print a string, print immediate. And there is a meta macro that is print, which just tries to detect what kind of arguments you give it and prints this to the screen. So it works almost as convenient as the print command in BASIC. There are stuff for clear screen, setting cursor position, new line. This is nothing magic, but it's convenient because it saves you the time looking up how to set the cursor position on these machines. There are commands for delaying some given milliseconds, multiplication and division, a function for identifying the SID. This, of course, is a C64 and C128 specific function. Same with the set raster IRQ function. There is one that's helping you disabling the NMI with a trick. There is a memcopy, memset. It's just a collection of stuff that might be quite useful. And I think it's good that it's there because at least when I need to quickly write some code, I use this stuff a lot instead of coding it anew or looking where I have done it before and copying from there. What's, in my opinion, the most interesting thing are the macros for structured programming. So there is a macro for next structure. So you can define a register that should go from a starting value to an end value with a given step. Step could go upwards or downwards. And it's closed with a next macro, and everything between for and next is then repeated with the register in between being adjusted, like in the basic for next function. There is support for doing if, else, and ending the if with an end if. There are loops, which are basically defined with do loop, and with until and while conditions, you can define how to exit the loop at some point. There's also support for break and continue, as you then probably if you do some C programming. There's a switch case. Not that known from other programming languages because you don't need it there, but in assembler you need it a lot. There is a function to store one of your registers and to restore it later. And what it does is to produce the self-modifying code to store the value of your register at the store point so that in restore it's loaded again. It can be also done, at least for the accumulator, it can be also done with pushing and pulling with the stack. The advantage of the store restore is that it is a bit faster and you don't have to take care that you hit the restore in any case. So with store restore, you can just jump out if you feel like it, and you don't have to worry that there is probably some unpulled accumulator value still on the stack. So it's a little bit more convenient. And of course, with X and Y, you can do it without using the accumulator. While if you do the stack version, you would have to transfer X to the accumulator, then putting it to the stack, then getting it back again, moving back to X, which basically clutters up your accumulator. For all these functions, I spend a lot of time into making them recursive. This was quite some effort because I had to come up with a clever way to create levels that depend on the recursion level. And I also could have used a scope and scope construction. But if I do this, then a user could not refer to labels inside loops anymore, or at least not easily with the standard naming scheme. And I didn't want to take this away from the user. So I came up with a solution that does not use scopes and just creates a lot of different labels. It's possible to have up to 9 different recursion levels. And there was still don't have to use scope. So this is something that went into there. So the most complex macro in this whole LAMAlib is actually the next macro. The next macro is several pages long, and it has to take care of so many conditions and so many possibilities that have to be taken into account. It's a bit crazy, but from a user's perspective, it's easy. You just write for next, and it's doing what you want, hopefully. For the if condition, I didn't go into providing passing of expressions, but rather made them operate on the flags of the processor. So have if or also until or while trigger on equal, not equal, minus, plus, on the carry being cleared, on the carry being set, on the overflow flag being cleared or set. And you can also use less than, greater, equal as conditions, but they're just based on the carry ones. Yeah, and that's the stuff for the structured programming. So now probably there is a question, how much overhead do I have to accept when using this kind of stuff? And I tried to bring in as many optimizations for loops as per possible. And for example, cases where a loop goes down to a 0 omits a compare in the loop instruction, a compare instruction in the loop, because you can just do it with checking on the equal sign after a decrement of the loop variable. If the loop goes down to 1, you can do it after this and can do it with branch no equal. So stuff like this has been implemented. And you see here 2 examples of defining loops. So there is a for loop that is clearing the SID registers, and it's using the X register, which goes down from the last SID register to 0, and it stores and then uses X as the index variable to store into D400. This is where the SID is mapped on the C64. And this generates the following code. And probably this is what an experienced programmer also would have written for exactly this purpose. So it's not doing anything very odd here or adding a lot of overhead here. The second example here is using a down to 1, and now you have to adjust the offset a little bit to make it doing the same stuff. But you see here that the loop that is generated, the code that is generated also is the same size. It's also quite efficient, and it has changed the condition on which the loop closes. So the first example uses a branch of plus, and the second one is branch not equal. So if it knows the end value of the variable, and it can use this in order to make a very efficient comparison, it does it. So if you compile this, for example, if you compare this, for example, to compiled C code, in this case, we would have to use, or at least I used the 16-bit loop to have a fair comparison. So I rewrote the clear registers stuff in LAMAlib with a 16-bit loop. So I had the AX register running from D400 to D41B. And then I'm using my poke AX, 0. I think this is easy to read. And the code that is generated from this is shown on the left side. If you compare this with a C program, where you also, I just named the variable here, AX. Of course, AX here is not the registers anymore, but this is a variable. And I also let it go over the same range. And I also used the poke macro here. The poke macro is explained above. And this is what you get here. And please note that we have like here 2 columns of code. So the generated code here is 2.5 times longer. So with LAMAlib, despite that there is support for structured programming, it is not a compiler. So it's not that we left the domain of assembler coding. It's still assembly coding, but it just became a little bit more convenient. But we're still efficient, we're still fast. Well, so to just quickly come up with my takeaway message. So if you already use CC64 and assembler CA64, then LAMAlib might be a nice add-on for you. And new programmers gain a reduced complexity, and experienced programmers gain the reduced complexity. It's something which it's always of some value. And the library is in continuous development, so new functions are to be added. If you have something where you say, oh, this might be a nice add-on and it's not there at the moment, please drop me a mail or write an issue on the GitHub page. If it's doable with reasonable effort, I'm very happy to do so. Currently, my next to-dos are for supporting high-res graphics. And also, there are many hardware accessing macros that are designed for C64. So I'm also planning to add support for the other machines, and especially for C128, there is a lot of large world to discover, especially when we look at the VDC chip, and this is currently missing, which is quite a big chapter to address, but this is definitely already on my to-do list. So you can get the newest version of it on the GitHub page. So Domits is my user there. So if you want to contact me, you can do it via this user on LAMAlib. And yeah, that leaves me to thank you very much for the invitation to being able to present LAMAlib here and for attending my talk.
Thank you, Wilfried. Thanks a lot. I see that there's a couple of questions. One from on Andre has already been answered. I see he was asking how large was the code created by the next macro, but then he said, okay, you answered the question. And then there's a question from Michel. If it's possible to nest, store, and restore. So he gives the example there to do store A.
Yes, it's possible.
Yeah. Okay.
Yes.
Good to know. Michel, do you have any follow-up question on that? Or?
No, I just wanted to know, because you said that you're not using the stack. So I just wanted to know if you just store the value in some specific place in memory, and can I use several store instructions and then it will restore everything properly? So if you're saying yes, then I'm very happy about that. That's all I wanted to know.
Yeah, I'm not using the stack, but I'm using self-modifying code. So the code example that you posted in the chat would generate code where the first store would store it to a label that is dynamically generated. The second store would store it to another label that is more deeply nested. The first restore would then have the label of the second store, as you suggested in your example, and the last restore then would fit to the first value.
Okay, so basically it depends on the order of store and restore instructions in the code.
Yes.
So I cannot jump between restores. I need to execute all the restores as they are written in the code.
No, actually, you could, for example, in the middle of your example, you wrote more stuff.
Yeah.
You could jump over the restore there and go to the last restore immediately, and it would give you the value from the first store.
Okay, yeah. Okay, that's cool then. That's very cool.
Perfect. I don't see more questions. Maybe I have a last one while I will then stop the recording. Maybe last one, because now of course you have posted this on your GitHub account. But do you know of any project that is making use of your LAMAlib? Any, I don't know, any known project or program where it has been used apart from I suppose your own code?
Of course, I have used it in my projects, but there is a colleague Pararam from the 7th division who is now using it also in his projects.
Okay. Okay.
He was also the first one to write an issue there.
Yeah, but that's why you need actually users, because then people can report if there is something not working as expected or something. Okay, I would say thanks a lot, Wilfried. I will now stop the recording. If there are more questions, then of course they can still be asked in the chat, and you can